Properties of enzyme. Enzyme are proteinaceous except ribonuclease and ribozyme. RNA content. Enzyme has primary, secondary, tertiary structure, but when you look at the 3-degree structure, you will notice active sites formed active site is one of to which the substrate binds. They speed up the reaction without being unleashed utilized. Sorry. Example: carboxylic carbonic anhydrase, fastest enzyme CO2 plus H2O. Without enzyme H2O CO3, only 200 H2CO3 formed in an hour. CO2 plus H2O और उसमें एंजाइम डाल दिया कार्बोनिक एनहाइड्रेज से, तो ये जो है 6 लाख H2CO3 फॉर्म पर सेकेंड. Working of enzyme. Activation energy. Activation energy, the energy needed by a substrate to convert into the product. Enzyme function by lowering down this activation energy. Transition state compulsory one or more than one unstable stage formed in between before the substrate converts into product. Finally, intermediate or transition state. Activation energy without enzyme. Activation energy with enzyme, it lower down activation energy. Transition state. This graph represents exothermic reaction, progress of reaction. Endothermic reaction. Without enzyme, activation energy is so high. Activation energy with enzyme lowers down. Potential energy increases, progress of reaction increases. Nature of enzyme action. Two theories explain the nature of enzyme action. Lock and key theory. Enzyme and substrate are complementary to each other since the beginning, just like lock and key. Enzyme substrate complex formation, EP complex. Slowly enzyme converts substrate into product. E and P separate. Enzyme and product separate. Second is induced fit theory. Active site. Enzyme and substrate are not complementary to each other. Enzyme and substrate are not complementary to each other since the beginning. When substrate comes closer to enzyme, the enzyme's active site get altered, induced changes so that now it can complement the substrate. ES complex, EP complex, enzyme plus product. When substrate bind to enzyme, enzyme active site catalyze, mix and break same bond of substrate and convert it into product. Factors affecting enzyme activity. Enzyme activity, optimum temperature, the temperature at which enzyme shows maximum activity. Factors affecting enzymic activity. Enzyme activity, temperature, optimum temperature at which enzyme show maximum activity. With every 10 degrees Celsius rise in temperature, enzyme activity either doubles or becomes half towards optimum temperature. After optimum temperature, optimum temperature के पास जाएगा तो 10 डिग्री राइज में डबल हो जाएगा, और अगर ऑप्टिमम टेम्परेचर से दूर आगे मतलब दूर जाएगा आफ्टर, तो उसके बाद बढ़ेगा तो फिर उसका हाफ हो जाएगा. pH, enzyme activity, optimum pH. Enzyme activity increases optimum pH at which enzyme show its activity highest. Substrate, with increase in substrate concentration, reaction velocity increases till it reaches velocity maximum, reaction maximum velocity. Further increase in substrate concentration count increase reaction velocity as all active sites of enzymes are occupied. Vmax is equal to maximum velocity km. The substrate concentration at which half of the Vmax is achieved. Michaelis maintain constant Km, at which V is equal to Vmax 2. Km is inversely proportional to efficiency of enzyme. Inhibitors are the substance whose presence is responsible for decline in the reaction velocity. Inhibitors are the substance whose presence is responsible for decline in the reaction velocity. Competitive inhibition, when inhibitor closely resemble the substrate in its molecular structure and inhibits the activity of enzyme. Consequently both fights to bind to active site. Hence, substrate unable to bind enzyme action declines. Enzyme substrate inhibitor looks exactly like the substrate. Substrate and I compete with each other. Substrate and inhibitors compete with each other to bind to the active site. Example, malonate is a competitive inhibitor. Of succinate for enzyme succinate dehydrogenase. Often such competitive inhibitor used in control of bacterial pathogen. Malonate is a competitive inhibitor. Malonate is a competitive inhibitor of succinate for enzyme succinate dehydrogenase. Malonate is a competitive succinate for succinate enzyme succinate dehydrogenase. Often such competitive inhibitor used in control of bacterial pathogen. Classification of enzyme. Enzyme are given EC number 4-digit code. Enzyme classification is, for example, class, subclass, 4 to 13. Each class further divided into subclass. Enzyme reaction catalyzed. क्लास ऑफ एंजाइम 6 क्लास क्लास ऑफ एंजाइम 6 क्लास होता है. ऑक्सीडो रिडक्टेज, transferase, second, third hydrolase, fourth lyase, fifth isomerase, sixth ligase. Class of enzyme 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 6 class: oxidoreductase, transferase, hydrolase, lyase, isomerase, ligase. Oxidoreductase enzyme which catalyzes oxidation as well as reduction. Enzyme which catalyzes oxidation as well as reduction in a chemical reaction, also known as dehydrogenase. S oxidized, S reduced, S reduced, S oxidized, H dash. अच्छा S oxidized, H dash reduced, तो S reduced हो जाता है और H dash oxidized. Transferase, enzyme catalyzing transfer of group other than hydrogen. Enzymes catalyzing transfer of groups other than hydrogen. Enzymes catalyzing transfer of groups other than hydrogen. Catalyzing enzymes catalyzing transfer of groups other than enzymes catalyzing transfer of groups other than hydrogen. 5 एंजाइम कैटालाइजिंग ट्रांसफर ऑफ ग्रुप अदर देन हाइड्रोजन को ट्रांसफर कराता है एस जी एच डैश तो एस प्लस एच डैश जी नो ट्रांसफर ऑफ एच इज नॉट ट्रांसफरेज ट्रांसफर ऑफ एच इज नॉट ट्रांसफरेज हाइड्रोलेज एंजाइम कैटालाइजिंग हाइड्रोलिसिस ऑफ एस्टर बाय either peptide glycosidic carbon 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 halide or pn bond all digestive enzyme lipase protease sucrase hydrolase enzyme catalyzing hydrolysis of ester either ether peptide glycosidic cc carbon halide or pn bond example all digestive enzyme lipase protease sucrase lyase enzyme that catalyze removal of group from substrate by mechanism other than hydrolysis leaving double bonds enzyme that catalyzes removal of group from substrate by mechanism other than hydrolysis leaving double bond lyase. Isomerase includes all enzyme catalyzing interconversion of optical geometry. Isomerase including all enzyme catalyzing interconversion of optical, geometrical or positional isomer. Ligase enzyme which catalyze formation of bond between compound. Ligase enzyme which catalyze formation of bond between compound carbon S, carbon oxygen, carbon nitrogen. Cofactors enzyme are composed of one or several polypeptide one or several polypeptide chain. However, there are a number of cases in which non-protein constituent called cofactors. Cofactors are bound to the enzyme to make the enzyme catalytically active. Cofactor enzymes are composed of one or several polypeptide chain. However, there are a number of cases in which non-protein constituent called cofactors are bound to the enzyme to make the enzyme catalytically active. Holoenzyme, it is a complete enzyme which consists of apoenzyme, protein part, cofactor, non-protein part. Holoenzyme, it is a complete enzyme which consists of holoenzyme, it is a holoenzyme, it is a complete enzyme which consists of apoenzyme, protein part, cofactor, non-protein part. Apoenzyme, protein part requires the cofactor for its activity. Apoenzyme protein part requires the cofactor for its activity. Cofactor non-protein part non-protein part पहला coenzyme, दूसरा prosthetic group, तीसरा metal ion. Coenzyme organic part. Coenzyme are the cofactor that are loosely attached to the apoenzyme. Temporary vitamins are essential component of coenzyme. Vitamins are essential component of coenzyme. Example NAD and NADP. Nicotinamide adenine dinucleotide. NAD nicotinamide adenine dinucleotide. Niacin vitamin is the component. Nicotinamide adenine dinucleotide phosphate. Prosthetic group are the cofactors that are tightly bound to apoenzyme. Heme is the prosthetic group of enzyme peroxidase and catalase. 2H2O H2O2 peroxidase catalase 2H2O. Metal ion. These are the inorganic part which is not only attached to the apoenzyme but also to the side of chain of substrate. Metal ion. These are inorganic part which is not only attached to the apoenzyme but also to the side chain of substrate. Example zinc plus 2, carboxypeptidase, carbonic anhydrase. Example: Zn+2 carboxypeptidase carbonic anhydrase, chlorine minus salivary amylase. Zn+2 carboxypeptidase carbonic anhydrase, carboxypeptidase carbonic anhydrase, carboxypeptidase carbonic anhydrase, salivary amylase, chlorine minus. Note: catalytic activity is lost when the cofactor is removed. Catalytic activity is lost when the cofactor is removed from the enzyme, which testifies that they play a crucial role in the catalytic activity of enzyme. Group, subgroup, class, subclass, subclass, enzyme reaction catalyzed. Class, subclass, subclass, enzyme reaction catalyzed.